Okay, we continue mograph menu, and here is the MoSpline. And in this lesson, I want to explain the turtle mode of the MoSpline. This is a turtle mode. That is you can programming this MoSpline with a formula. If you go to the turtle, here it's the formula here. You can write any formula here. Okay, I want to explain this complex settings by some examples, and and after that you can understanding the basic of that. This isn't presume and the rules. This isn't just a formula. You have to write the formula here, and in this formula we have a variable called a, for example, and or f, af. We have two letter here, and then you have to assign, for example, a is what. I explain it. Okay, we have nothing. As you can see, we have any mograph here, any MoSpline here. Turn your caps lock or holding shift and press F. F means move forward. If you click here, as you can see, it move forward. It's one segment of the MoSpline that move forward. Move forward in which length? Here is the value. You have to change the range. This is a growth. Growth is the most important thing. I explained it is changing the growth to the 1. This is a play. Actually, this is a play mode of the. If you increase it, you can grow your MoSpline, but you have to write the right formula here. So this is the most important. Default angle. What is default angle here? For example, 45. If you tell the formula, okay, rotate, in which angle rotate, or which scale do you want, or which movement? This is an forward. F is forward. Go forward 10 millimeter. As you can see, if you turn the work plane, go, as you can see, 2 of this spacing grid is 10 centimeter. You can change it anytime that you want. Nice. And I explain them later. You can make them 0. In this case, I explain them later. Okay, so this is move 1 forward. Go to the turtle. And then we have something called rotation. 2D rotation and 3D rotation. If I want to explain the 2D rotation, for example. The 2D rotation is plus or negative. It means, okay, go forward and then type plus. It means, okay, rotate in a degree that you define in an angle 145 degree to the right. Okay, why didn't you see it here? Because this is in one segment. You need, okay, rotate, then create another segment to see that. Another segment is Shift F, caps lock F. And then, as you can see, it rotates in this axis 45. If you want to double it, you can make it 90 degree. As you can see, you can change the degree here, any degree that you want. Or you can double this angle to 90. You can make plus. It means rotate 2. And as you can see, it's rotating in this direction. Or if you want to rotate in another direction, you can type negative to this direction. Or 1 negative, and then change the angle that you want. Okay, you can change the angle, for example, 90 degree. Okay, this is just about rotation, and that's it. Okay, give you another example here that you can understand. It's very easy. First example I want to explain is to creating this triangle here. For that, I tell you, okay, go forward. The default angle is 60. Go forward, then double rotate to the right, then go forward, as you can see, then double rotate to the negative, Oh, sorry. And then go forward. Oh, no. Another double plus. Yeah, let's go in direction. As you can see, we have an triangle. So I want to add a rule here. I want to loop it. If you go to the value and growth it, as you can see, it does not grow anymore. Go to the turtle and add a formula, add a rule. Okay, you can define, okay, this f here, you can replace it with another formula here. Type f is equals which another formula? I want to create this. As you can see, this isn't just formula that you can create. This formula, you can write it. Go forward, for example, in this direction, go forward, then go forward, then right to the left with a 60 degree, then go forward, then plus, and you can see, you can write this formula for by yourself. But I type it there and a variable. F, then negative, right, go forward, then go to the right with double angle, and then F, and then go back again. This is an R formula. And this formula here is replacing to any F here. And if you go to the growth, here you can go to the object and turn your line. And as you can see, in this growth, you can grow that object. It's looping. Interesting. What happened? You can see this in image. First, we create in a growth one this triangle. And we loop, for example, this is one F. With this F, we replace this formula to this segment here. And it's create this. Imagine. And in any segment here, we loop and replace another formula, exactly this. F is equal is to this formula. This formula here is exactly this shape that you learn it. We replace it to any segment of that. It means, okay, as you can see, this is on one F, one forward, rotate. And then we create this formula and replace it with this segment. And it is repeat and repeat and repeat. Okay, I hope you understand it. Going to give you another example to working better. In this case, I want to, okay, go forward. Oh, as you can see, you have to write capital F. Go forward. And the values growth 1. Default angle in this case is 19. Nice. This is our object. You can go to the object and turn it to the full shape to better see that. Go forward. And in this case, I want to explain a variable. A. Okay. It's nothing happened because you have to define what is this A in a rule. Okay. A is equal to this formula. First, before that, if you want to from the beginning rotate before going to forward, you can type plus and then F. From the beginning, it's turn right. You can do it like this, okay? So we type F and then A, and I want to explain what is the A. The A is equal and something formula here, plus F negative F. Okay, what happened here? This is a more of formula. If you go to the variable and growth it, as you can see, it just growth 1. This is our formula that I created here. It's go to the rotate 90 degree here, and then go to the negative and go forward. This is one formula. and it just grows one. It means it repeats just once. If you want to repeat it for a loop, if you create a variable here, type it again here, and it's loop. It's very simple. If you replace this formula to this here, at the end of that formula, we have another A. And the A is exactly again this formula. And in this structure, it's looping. And if you growth, grows. This isn't growth. As you can see, just repeat that formula. So in this lesson, you learn repeat mode. Okay, go to another example for branching. You learn another interesting type code. Okay. Let's change the value to a smaller number to see the branches. Okay, I tell it, okay, go forward. And in a branching, you create another segment independently from this. You have to create a quotation, close and bracket, sorry, open and close bracket. Open and close bracket, it means, okay, we have a separate formula inside it. In this case, I type plus F, plus F in that. And as you can see, we have a separate segment that have in a positive angle 30 degree in this direction. And then another F. As you can see, this open close bracket here just create a branch in between this and this. What happened here? As you can see, we have FF. Okay, it means two forward to ahead. Okay, in between them, you can open close bracket. It means from the exactly in middle of this, you create another MoSpline. You can type negative F if you want. If you want to in this direction go up, you can tell it another F, double F. If you want to branch in between them, in between those F, you can open close bracket. In this bracket, you can create another F branching there. Sorry, negative F. And you can branch it there. And this is our formula. And if you type F, another F here, it's continue its way here. Or you can type it, okay, plus. It's branching there. Okay, you can understand it's very easy. Okay, this is our formula. This is our formula. It's very easy. Control X, and you can type F equal that formula that we create, and hit the F here. And as you can see, it's branching, and with the growth, you can turn the growth off. And as you can see, we can repeat and repeat that formula and growth something. Oh, interesting. And as you can see, because we have an F and an F the first, it's looping. Okay, this is on branching. You can define it. Okay, I give you another example for understanding another code for 3D rotation. As you can see, all of these turtles are in 2D rotation, 3D rotation. Look at this image. This is our turtle. Backspace. Sorry. This is a backslash, and the slash is rotating in this direction for a slash, and the caret holding shift and type in a 6, and the and is rotating in this direction. We want to explain this formula here. What happened? First, F. Our turtle is going forward into the direction. If you type and, and rotating in this direction. Go 3D in this direction, then go forward and backslash in the parentheses 90°. It means it's rotating this direction. It's very important because if you want to angle here, it's very important to define the parentheses to don't confusing the formula. And then go to this direction. Okay, let's test it. First, go forward. Nice. And rotate another forward. Yep. You define the angle here, for example, at 90. Nice. And as you can see, it's going in 3D. Nice. Our growth it's not important if you type any rule here. It's the growth is not important in this case. I'll just turn it 1. And then, okay, I want to backslash rotate in some. If you backslash F, it's go exactly this, because the slash and backslash is rotating in this angle. As you can see, it does not work. Before F, we want to tell it, okay, rotate backslash in open close parentheses in 90°. Nice. And then caret forward and go in this direction. Look at that image and you can understand it's very easy. And if you want to go and another and F, yeah, caret F. As you can see, you can create it. And you can loop this formula to your roles if you want. Another, for our last example, I want to explain another special rotation that we can use to our example for creating something. Okay, we go to the F, go forward, and you can hold in Shift backslash, Shift backslash, create this code. It means it's rotation in its vertex angle axis. It means it's rotate based on this vertex, last vertex here. And I want to rotate in 180°. Change it to the 180. And I want to loop it. So if you want to loop it, you can add a variable to that, A. Nothing happened. You have to define what is that A. A equal your formula. For example, I want to negative go forward, and then I want to loop this rotation. Then I want to exactly copy this formula here. We can Control C and Control V here. Exactly, I copied that formula here. I want to loop it. It means if you begin from it's go forward, rotate with this formula, and it want to execute A is again this formula, and then it's to go to infinite loop. Think it about that, you can understand it easy. And in this case, if you turn the growth, and as you can see, we have this nice opening to infinity. And the most important thing about is this, that you can assign this MoSpline to your extrude. And look at how interesting work that you can do. Go to our MoSpline and open it. Nice. Okay. You can go to the extrude and direction, for example, in a which direction? In a X, if you want. You can change it X. But in this angle, it's not working. So, as you can see, you can see opening of that. Or you can go to the third value and increase the number of the lengths. we have more lengths of in each segment if you growth it. Nice. Imagine how interesting work we can do with this MoSpline. Okay, we create another MoSpline. It has a lot of other coding that's very complex. If we finish the listening, I think I come back and give you some interesting other formula. But in this case, it's the turtle. We have some other thing here, like trapezium. The trapezium is something like this. You can change your branching. These options are for branching, like a tree. Trapezium. You can add a randomness to your position. The move multiplier in this turtle, as you can see, we have very complex rules here. A, B. In a rules, we have a B, and then a B is this formula. It's a very complex. But we have a quotation here. Okay, we have a quotation code here. This quotation code allow us to multiply the movement. As you can see, just move your object. But if you growth it, it just growth your tree, not movement. So this is a movement multiplier or angle multiplier in this case, or scale multiplier. And if you want to grow to angle, grow to a scale, or if you don't want to grow to movements, you can turn it off. And just angle is, as you can see, the angle just grows, not the movement. And you can give a vector, the force, as I said before, in your branch. Unfortunately, it's very hard and you need to have understanding and thinking about the formula, but you learn a basic of the MoSpline. Hello, my friends. To continue these tutorials on YouTube, subscribe us, like us, and hit the bell icon. And now you will be alerted about all of the amazing videos that we release.